Welcome to Pint of Science 2021. My name is Evie and I'm a PhD researcher at the University of Warwick, where we're all coming from tonight. So far, the Pint of Science Festival has been awesome. There's been some great talks and events going on this week. And for the University of Warwick, it is particularly special because it sits right at the start of our Resonate Festival, which is going to be a year-long event as part of our City of Culture celebrations in Coventry, our home city. And tonight's session is particularly fitting because of Coventry's well-known past in rich automotive history. So over the next hour, we're going to be discussing various projects on sustainable materials and how it links to motorsport. And this is the Tech Me Out session. So we'd love to hear from you. We want to know where you're coming from today and where you're watching. So please use the comment section to tell us where you're viewing from. Over the next hour, we're going to be discussing these sustainable materials for motorsport. We're going to be looking into a community project and seeing what our student engineers get up to in the motorsport sector too. So I would also like to hear from you, not only in the chat today, but on social media. Please use hashtag Pint21 to let us know and join us in the conversation, and also at Warwick Engages to talk to the university directly. So I'd like to start off with a video about our famous chocolate racing car. At the moment, we've got one person here from Manchester. Let's hear from some more people. We're going to start off with the video of our chocolate racing car, which was a project started over 10 years ago now, but it captured the imagination not only of our researchers and our students, but also all over the world. Not only is it got a carrot steering wheel and is powered by chocolate, but it is also super speedy. So let's see that now.
World First really was conceived because of the popularity of Eco 1. People wanted something that was going to be bigger, faster. So we came up with the idea, and hopefully it's also greener as well than Eco 1 was. As engineers and scientists, what we try and do is say, well, you know, be pragmatic. People are going to want to do these things, and we have to come up with the solutions to allow them to do it, but mitigate the environmental damage that they may cause.
What we've discovered is that a racing car is a fantastic way to demonstrate all these new materials and actually tell the world about them and try and get people thinking about their use and where they might be used in motorsport and indeed in real world cars.
This car has got a whole raft of green technologies on board, from recycled materials to natural materials to some fun chemistry that converts ozone to oxygen. The fuel systems are different, the engine management system is being redeveloped, a whole raft of green technologies. So really it's up to industry to have a look at what we're doing and see it as the benchmark if they want to be environmentally responsible. The students benefit simply because it's real. They can see the fruits of their labour, and it's not set in stone either, so there's always chances for future students to get involved, and it will evolve over time into a new beast as we progress.
Brilliant. So I'm imagining this is bringing back some great memories for some of our speakers today. So I think it's about time to introduce our panel. Starting off, we have Professor Kerry Kirwan, who is the Deputy Pro-Vice Chancellor of Research at the University of Warwick, a trustee in the Alan Turing Institute, and head of the Sustainable Materials and Manufacturing Doctoral Training Centre. There's a lot of big words. Oof. Next up, we have Dr. James Meredith. He is managing the Very Light Rail R&D project at WMG, the University of Warwick, an expert in biocomposite materials from his doctoral work, and also has a lot of experience in the automotive industry. We also have Dr. Steve Lambert. He is head of electrification at McLaren Applied and chairman of the Automotive Electronic Systems Innovation Network, and also a fellow Warwick alumni. all three here have worked on the amazing sustainable racing project that you just took a glimpse at. But we also have one more panelist. This is Iqra Hamid. She is a recent Warwick graduate with a master's in mechanical engineering, where she also led the very first electric vehicle entry from the student-led Warwick racing team into the Formula Student competition. Wow, welcome everybody. It's great to see you here. So maybe I can start off with Kerry. Can you have a bit of a comment on the video we've just seen, and maybe how the car came about, and yeah, how did it first come about?
Well, first of all, I must apologise for that tank top I was wearing in that video. I forgot all about that, to be honest with you. Thanks for bringing that back to me. So, I mean, it came about, the whole racing concept came about down in Cornwall, believe it or not, at the Eden project. We were down there for a sustainable composites meeting, and the conversation came about they were going to hold a sexy green car show. And people were sort of talking about taking a wing mirror or a tyre or something like that. And we said, well, perhaps we'll do a whole car. And then having said that and being taken up on that, we had a minor panic and then looked around to see what we could do and came up with the Eco 1 concept, which was basically our little student racing car. And we took that and then put on it a few green technologies that we were working with companies. And it was really, really well, became very famous. And then we went from there, and people wanted bigger and better and more. So that's where the whole world first concept came from.
Brilliant. So before this point, was there really many sustainable materials in the automotive or motorsport sector?
I think, to be fair, I mean, most things were sort of concentrating on fuels, I think, at the time. So there was a lot of work going on bioethanol and things like that, which we did use in Eco 1. But no, I mean, there was sort of an interest in their potential, and that's what we tried to show off, was just how good these materials could be in really demanding environments.
I think it's one of the things we discovered almost, is that sustainable materials weren't used because they didn't make the car go faster, and they didn't help you win races. And I think that was almost what we wanted to try and prove, was that actually, you know what, some of these materials were good enough to do, very demanding applications, basically.
But I think as well, it's worth remembering, one of the things we did was look at what was available out there in the market in other industries. So when you look at some of the bodywork for Eco 1, for example, I think that came from marine industry project, for example, that we then bought into automotive and motorsport. So, you know, there's stuff out there, but it's understanding where it is and how you get hold of it.
Wow, that's really interesting. So maybe we can go on to Iqra. You involved with Warwick Racing, which is a student-run racing project. Maybe you can tell us a bit more about how it all started.
Yeah, absolutely. So Warwick Racing has been around for a very, very long time. Established in 2002 as an academic project for students in their final year of their master's course to really get involved, design, manufacture, and race a Formula Student car at Silverstone each year. Now, for those who are unfamiliar with Formula Student, it's an event organized by the IMechE, where universities from across the globe design and manufacture Formula Student cars, race them at Silverstone, and are assessed on a variety of events. That includes sort of statics, where they present designs, cost and manufacture, take part in business case studies, as well as the more exciting dynamic events. So once the car's passed scrutineering, it'll take part in dynamic events such as the acceleration and endurance events. And a few years ago, Warwick Racing actually became an extracurricular project, so opening up doors to students from all years, degrees, and backgrounds, and really giving everyone an opportunity to get involved with the project, both with regards to the technical build as well as the business division. And more recently, we've made the jump to develop a electric Formula Student car, which has been challenging yet a very rewarding time for the team.
Wow. So you were doing your engineering degree and this in your spare time?
Yep.
Impressive. Very impressive. So maybe, Kerry, can you comment on why this is so important to build and race these cars for the students?
I think Iqra's just covered it really well. It's that chance to bring the real world into their studies. So it's it's hands-on. It's testing things, and it will also involve things failing and going wrong, and actually that's a great way to learn. The theory is there, but actually getting hands on and doing it in the real world is something that is just absolutely invaluable. and puts them in a really good stead for future sort of occupations in engineering and various other sort of industries.
Yeah, definitely, for sure. So maybe either Kerry, James, or Steve, can you tell us a bit more about like the materials that were on the Eco One and the world's first car? Which materials are we going to be most surprised by?
So I think probably the ones that captured the imagination best, but I think the ones as you introduced it were very much the fact that it ran on waste chocolate. So we used essentially the cocoa butter from waste chocolate. Most people don't think there is any waste from the chocolate manufacturing process, but cocoa butter is one of those, and that can be turned into a fuel. And obviously we put a diesel engine into this vehicle to enable us to run on these sort of biodiesel fuels. And the other one that was extremely well received, should I say, or popular was the steering wheel made of carrots. So if you take carrot juice and you get left with a sort of cellulose pulp at the end of making your juice, you can then take those cellulose fibers and make them into a reinforced polymer, which we then use to manufacture the steering wheel. So that was certainly seen as a very good thing. And we had a number of other foodstuffs on the vehicle. I think we made wing mirrors from potato starch, and soybean oil was used to manufacture the foam in the seat. Kerry, can you think of any others?
No, I mean the wing mirrors were good fun. They're actually, believe it or not, they were made in New Zealand, and the prototypes looked like we strapped two sort of big mat wrappers to the side of the car, and when it hit 50 miles an hour, they sort of go poof and disappear behind you. So they needed a bit of work on them. The other interesting one was with waste chocolate, which was a revelation, was that we used waste wine as well as an additive for it, which was another revelation because nobody knew there was such a thing as waste wine either, but apparently there is. I kind of like the ozone-eating catalyst on the radiator, so it converted ozone to oxygen as it went round. So just again doing a little bit of CO2 balancing on this track day sort of thing.
Yeah, and it wasn't just the materials. It was all about there's some sort of recyclability aspects to it as well. So when we started designing it was looking at actually at the end of life, how do we get rid of it? How do we recycle it? For example, the wiring loom. You've got copper and you've got aluminium in wiring harnesses, very recyclable. You've got to put a lot of energy into actually breaking it down to get there. So we designed that to be easily recyclable, as well as having low halogen materials in there and that sort of thing.
Yeah, that's really impressive that how you had this kind of. Oh, sorry. I'm impressed how you had this kind of like oversight to see that, like, what its end of life would be, as well as how it's going to function. And I'm very surprised that you had any waste chocolate and waste wine to use. If it was up to me, don't think you would.
I think most people are very surprised by that. It is amazing what waste streams are, and actually the value that they can have for turning into useful things.
Yeah, definitely. So obviously you've made all these different new innovative materials, but who did you work with? Who did you collaborate with to do this?
Well, I think we were really fortunate right at the start of the project. We were searching around. Essentially, we knew we wanted to make it bigger than better than Eco One, and we started looking around for UK manufacturers of racing vehicles. We didn't quite know what car we'd use, but obviously we had Lola, who were just about an hour or so down the road, and we were very fortunate to have them because not only were they able to provide us with a Formula 3 car, but also the expertise required to actually manufacture bits. They had all the tools that went with it to make parts, and the expertise to put it all together into what was essentially a very high performance racing car. So we were very lucky to find Lola to actually support us with the vehicle itself. But then I think as soon as we got going with the vehicle, it became clear that people would be very excited to be involved, and there were many companies who were keen. I think BASF on those radiators that Kerry mentioned, a number of natural fiber composites and recycled carbon fiber composites, obviously the carrot fiber steering wheel, and the companies to help us engineer the engine and all the the recalibration of that engine to make it run on different fuels. Companies like Steve mentioned, the wiring loom. We had Yazaki, who were just based down the road, who actually helped us manufacture the loom and put some of their sustainability ideas into that, like aluminium wiring and such like. your plant-based oils from Foosh, and I think it was just a really sort of exciting thing that, and people were very keen to get involved with it. Really, I even took the company called Life, who are the guys who really helped us make it all look pretty as well, and actually did the the sort of image of the wrap on the car and such like. So there were really good examples of people getting involved and very keen to help us out.
And I think it's worth mentioning, this is it was a proper racing car. Formula 3 is a proper professional or semi-professional race series. It's not, it wasn't a typical university type of project where you throw some sort of nice stuff onto a banner and make it look good. It was a proper fast racing car. I can attest to that. I think I was the first person to spin the car on the track and realised that racing cars wasn't my forte. But it was an exciting project. It was something that you could get excited about, get your teeth into, and want to be involved in. I think that that's why we got so many people to help us out with it.
Yeah, that's brilliant, and it's great to hear that you've got quite a lot of local collaborators as well, because obviously that helps keeping the car green when you are building it. Obviously you've spoke about it quite positively so far, but what were the big challenges that were involved?
Plenty. I think we realised quite quickly we'd bitten off quite a lot more than we could chew, to be honest with you. But actually, do you know what? We, like I said, with the right people, we had Kerry involved, Steve, myself, another NGD student, Ben, was involved as well. And actually, between us, we managed to put it all together, and we had great support internally from technicians and such like. Plus, loads of other companies involved. So it came together in approximately 12 months. And then we were able to drive it, which is obviously whether we could get away with doing the same things now, I don't quite know. We started off in the car park, pottering around, and obviously it graduated to sort of Brands Hatch and Rockingham, driving it quite quickly. So it was really quite an exciting project, to be honest.
I think it's worth saying James has been quite kind to himself there. I think it was a Herculean effort from him to get up and running. It wasn't I think Kerry kind of threw this grenade over the wall and said, "Here you go, James, run with this." And actually, it was it was a good effort by James to get the whole thing pulled together. Steve,
I couldn't have done it without you, mate. You were luckily Steve was in the unfortunate position of sitting beside me and knowing something about wiring.
Yeah. Well, obviously this was a big effort to make, and you did it in very impressive time to actually produce a full car, and then it became quite a bit of a star, didn't it?
It did. It literally went around the world. I think we went. I think we sort of went about 4 days without any sleep when we launched it. I remember doing interviews in supermarkets and things like that, and then all of a sudden it was America got hold of it, and it appeared it had a double page spread in Time magazine. It was one of the top inventions of that year in Time magazine. Put it this way, it went to Indianapolis. So when you go to Indianapolis with a racing car, you've kind of done something to make people pay attention. So it was absolutely bonkers.
It was, yeah. My brother lives in Peru, and he saw me on TV when it was being shown on TV in Peru, which was a bit weird.
Yeah, Japanese bullet trains as well. Apparently, it was on as well. Somebody saw it from work on a Japanese bullet train. It even made Sugarcraft and Baking Monthly, I believe. So.
Wow! So some really impressive press it got then. Really, wow. I'm just gonna take this opportunity to remind the audience if they've got any questions that they want to ask the panelists at the end of the session. That spring to mind, make sure you put them into the comments as we go. I'm going to move on then to Iqra. Your car that you guys have built looks pretty awesome too. Can you tell us a bit more about how this car is sustainable or eco?
Yeah, absolutely. So in terms of how the car's built and manufactured, the chassis itself is comprised of a steel tubular space frame with the majority of sort of structural components like bulkheads, powertrain mounts, brackets, uprights, and our battery cases made from aluminium alloys. And our bodywork, which you can see in the lovely picture, is actually designed from carbon fiber reinforced polymer panels, which we had received off the back of a research project in WMG. Now, regarding sustainability, what we found is over the years that there are limitations sort of in place with certain materials and processes that you can use with a competition entry, whether that be rules, regulations, experience, and just manufacture in general. So what we tend to do is take more of a sustainable approach where we can in the project. And that would be things like recycling and limiting the waste by using materials and components from either previous cars or any stock that we already have. We like to use more efficient manufacturing processes that result in less waste, and probably the biggest one being how we source components. So we want to do that in a sustainable fashion. So things like our battery cells and the carbon fiber bodywork, to name a few, have all been sourced sort of off the back of other projects, which if we didn't, would have gone to waste otherwise.
Oh, that's really good. And I like the idea that you're slowly passing parts from the different cars down into the newest model, which is really nice. So obviously you've made this great new car. What were the specs? How fast could it go, and where did you test it?
Well, we've done a few test sessions at Bruntingthorpe and have a few more planned, so keep an eye out for that. We usually, we'll be planning to run it at the Formula Student UK competition later on in July. And in terms of the spec, so our current race entry, it features a single motor powertrain that's limited to 80 kilowatts, thanks to the Formula Student rulebook. And that's run with our 6.5 kilowatt hour battery packs, which we've actually developed in-house ourselves. And whilst we haven't yet fully tested the maximum performance of the car, we have achieved a 0 to 60 time of 4.1 seconds at our last test session. And the car itself has been designed to finish the endurance race, which is 22 kilometers in range.
Wow, that is impressive. And all done by students and parts built in-house.
Yeah,
wow.
All students and support from the technical staff at WMG.
Yeah, that's really good. Maybe we can see how it shapes up versus the world's first car then. Maybe, Steve, you can tell us how fast you drove it, especially when you spun it out. What speeds could it produce?
Yeah, I'm not sure what speed it could produce. What I do know is that it's a really funny car to drive because it's got aerodynamics on, and if you unless you've driven something with aerodynamics on, you probably won't get this. But it sticks to the corners really, really well. And so what happens is you go around a corner and you go, oh, that's okay. I could go faster around that corner next time. So you go on the track again, and you go a bit faster, and you go, oh, I can go a bit faster, and you keep doing that until eventually you run out of talent. And I did that quite early and spun off quite spectacularly. Top speed wise, I'm not sure. I can't remember. James, can you remember?
I think it was we were, because of the diesel engine, we were slightly limited. I think it was geared to 146 miles an hour or something like that. So it wasn't like 200 miles an hour or anything like that, but it was certainly quick. And as Steve said, actually the driving experience was really amazing. It was genuinely fast car. Yeah, I think it probably the power output was a proper racing car. Yeah, but by the time we finished with the engine calibration, it had more power than a normal F3 car. So it was certainly suitably, quick, shall we say.
And the diesel engine gave it massive torque, didn't it, as well?
Yeah, it rattled your eyeballs.
Yeah. If you didn't breathe in before you went, you run the risk of suffocating by the time you got to the corner.
So
it was a little bit smoky.
So where did you test it then?
Oh, all over the place. So yeah, we started in the car park. It was really tricky to get going. The clutch was, we thought the clutch was very tricky, but when we put a professional racing driver in it, they certainly didn't find it too difficult. But anyway, we've probably got videos of us taking 20 attempts to get it going. But I think, so we started in the car park, and then we went to places like Bruntingthorpe and anywhere in, with a straight bit of tarmac. And then Rockingham were really great. I mean, Rockingham, I don't think they're a track now, are they? But either way, they were really, really great to us. They said we could come and use the track. I think we had exclusive use and had some professional drivers take it around there. And then eventually it sort of culminated in arriving at Brands Hatch with Aaron Steele as the driver. And we tried to enter it into a BRSCC F3 race, historic F3 race. But sadly, we sort of got to qualifying, and then it all got a bit difficult, and we didn't quite meet the right standards, and And I'm sure Kerry can tell the story better, but basically we ended up just doing some demonstration laps. And then I suppose probably one of the more fun events was Goodwood, and maybe Steve or Kerry can talk about that. I mean, it was great. We got to, essentially there's 2 runs a day over 3 days, and I think we had to go driving up the hill and got involved with the professional drivers. Everyone got dressed up for the occasion, and it was a fabulous end to the project, probably. Steve.
Yeah, I mean, I don't know if you can see that. You've got Lewis Hamilton there looking at the car. We were actually at the if you know Goodwood, they've got the starting straight, and the cars kind of line up there. And Lewis was there with one of the McLarens, and he came over and go, oh, what's this? And Adam Carroll was driving it that day. He's actually gone on to be I think he was the A1 GP champion at the time. He went on to Formula E and various other things. So we had some serious interest from drivers there as to the car and what it was. But as you say, it was a great event to be at. Just being in the middle of all of that, in the middle of that sort of huge motorsport event was a great experience.
That's brilliant. So why is it? Maybe I can ask Kerry. Why is it so important to research sustainable motorsport?
So, well, I mean, motorsport, excuse the pun, is a great vehicle to show people what materials and these sort of technologies can do. So it's very fast moving, and it allows us to do things that perhaps the more conventional industries need a bit more time to get to grips with. So that's the first thing. The second thing is it's really demanding, so it puts these things really to the test. And if they don't fail, they're probably going to be very good for other things as well. And thirdly, motorsport is really popular, and I mean, this was ahead of its time, and there is a real groundswell in environmental concern, but there's also still a huge number of people who enjoy motorsport. And we always think of F1, but actually, there's hundreds of thousands of people every weekend, or pre-COVID every weekend, who would go out and race their cars, whether they were Formula Ford or Porsche or even sort of 1920 sort of Aston Martin type things around for fun. So it really does reach a wide audience, and there is some potential to get some of this less environmentally damaging as it moves forward.
I think we really wanted to. I mean, at the time we did this car, there were a number of the materials which we used, but we didn't want to use on safety critical components, like the front crash structure or anything like that. But subsequent to doing the car, obviously we did a load of research and proved those materials as capable of actually delivering the performance needed. So I think you are beginning to see, I think some of the things we did are now creeping into motorsport. You are seeing natural fiber composites in motorsport. Steve, I mean, have you got any examples from McLaren or anything? But there's certainly some sustainability that's just creeping in at the edges, and I think maybe because when we started, certainly sustainability was almost a bit of a joke, I think, for Formula One or whatever, because it just didn't make the cars go fast. And I think that message is changing a little bit now.
So perhaps I can ask the panel now briefly about their current projects. So James, you're working on a different type of transport now. Could you briefly tell us about this project? So
very briefly, Coventry Very Light Rail. So most cities would love to have a light rail scheme in their cities, but they're very expensive. So places like Birmingham, Edinburgh, Nottingham and such, like they've got them because they cost sort of circa 50 to 100 million pounds per kilometre. But if you've got a smallish or medium city like Coventry, actually you can't really justify those costs. So you really need to try and achieve a cost of about 10 million pounds per kilometre. So, and that's the challenge that Coventry set us at the beginning of the project. They said, we'd love a light rail scheme, but we can't quite afford it. What can you do for us? And Very Light Rail is the concept that we've come up with. It involves these small vehicles, lightweight vehicles, running on a newly developed track form, which is low cost, in the ground, and basically it's a great, hopefully going to be a great sustainable thing for Coventry. And rail has got all sorts of benefits around low CO2 emissions and getting people out of cars and such like. And just a couple of things we've done. One of the previous images showed some red panels on the side of the vehicle, and we made those using recycled carbon fiber, which was sort of originally developed for the Formula 3 car. And there's other sustainable things on the vehicle, like we're looking at the seats now. Actually, we've used something called e-leather for the seats, and that is essentially a recycled leather, and it it's sort of, I think, about 55% recycled content. So a lot of the leather that would otherwise have ended, or the offcuts of leather that would have ended up in landfill, actually can get recycled into, you know, a proper, good quality leather material. So there's a number of sustainable things that we've done around the vehicle, but yeah, I'm really excited about it.
Yeah, that sounds brilliant, and it'd be a really good thing for Coventry too.
Certainly,
so
yeah.
Steve, obviously you're working for McLaren Applied now. Can you talk a bit about how you aim to make motorsport more sustainable?
Yeah, so there's on the sort of the Eco-F3 project, we looked at a lot of materials and what can be done there, and that's of course important. But the big area, certainly the motorsport is looking at and where it's having an effect, is electrification. So you probably can't find a motorsport series these days, or a professional motorsport series, that isn't at least looking at electrification or hybridization in some way, if it isn't already going there already. For example, so McLaren Applied, one of the things we do is we provide the battery into Formula E. Formula E is a all electric race series, and we do the standard battery that the whole grid uses. What's interesting about that battery, there's a picture of it on the screen. What's interesting is that it actually comes from some automotive technology that's been developed to go into Formula E. However, there's a lot of stuff that goes the other way from motorsport into automotive, and that, of course, is where really motorsport can have a big impact. A great example of this is in the drivetrain, in the motors and inverters. So when you're competing in Formula E, for example, but it's the same in Formula One and other things, it's actually a competition around efficiency. So it's not necessarily about being the fastest, it's about being the most efficient, and Formula E is all about the most efficient drivetrain. So we spent the last 7 or 8 years developing something called silicon carbide inverters, and that's essentially going to be the next the next big technology for automotive inverters of the future. The reason being is that they're much more efficient than the technology of today, and that's really going to be how you see, and there's a picture on the screen, that's going to be the main theme that you see coming out of motorsport and going into automotive as electrification takes hold across these industries, is making sure it's more efficient. Now, that can be more efficient in the drivetrain, but also includes things like being more efficient in the embedded carbon that you have, or more efficient in how you transport these things. And again, that's where some of these materials will come in, because if there's less embedded carbon in there, or they take less energy to manufacture or produce, then that's ultimately a good thing. And that's one area where motorsport is really making a difference, and you can see where that's having a wider impact in the wider automotive market.
Great. Well, we're going to be hearing about Kerry's current projects a bit later, so we won't go there for now. But I'd like to hear maybe from Iqra. Can you tell us a bit more about what the future looks for Warwick Racing?
Yeah, it's quite an exciting time for the team. More in regard to the short term, we have the Formula Student UK competition coming up in July. So the team are very busy preparing for that and are focusing on the final build and testing of the car before it actually hits the track at Silverstone. In addition to that, we've got our 2nd generation car, which has now entered the manufacture phase of the project, and that features a whole load of upgrades from our current car, including a dual motor powertrain architecture, new and improved battery packs, upgraded suspension system and chassis. And going one step beyond that, our 3rd generation car, is the development of that's already underway. So there's a lot to look forward to in terms of new and upcoming vehicles. Aside from our EV development, we've also got the team sort of researching into the potential of an autonomous entry as well. That's something quite new with Formula students. So that's an opportunity for a lot more learning and a new direction for the team. So yeah, there's a lot to look forward to, and it'll be exciting to see how it all unfolds.
Well, just one last sentence then from Steve. Looking forward to the future, what do you see as the future for motorsport?
Yeah, so this is where I do an unashamed McLaren Applied plug. We did a piece of work looking at future of Grand Prix. You can have a look at the blog on our website. But essentially, it is an electric racing car concept for 2050. We know that we're pretty sure that by 2050 all motorsport is going to be electric. But it could also have interesting things like movable aerodynamics, energy transfer from track to the car, and all sorts of driver aids and AI support in the drivers as well. But it really is a thought experiment as to what is the future of motorsport going to be in 30 years' time. So
Brilliant.
Please check it out.
Awesome. That's really good place to end our panel discussion on. So thank you all. We will hear from you again later in the Q&A session. So if the audience have any more questions, please pop them in the chat as you go. So now we're going to take a look at an exciting local community project. Iqra, can you tell us a bit more about it?
Sure. So for many years, Warwick Racing have taken on projects looking to support the local community and inspire the next generation. This year, they've teamed up with Fridays, who are a local youth group based in Coventry, with the aim of sharing knowledge and sort of providing an opportunity to get involved with engineering. Now, whilst the team themselves can't be here and join us live today, what they have done is prepared a video explaining the collaboration in a bit more detail, but more importantly, how much it actually means to those involved.
Friday's Coventry is a youth initiative I set up to prevent knife crime and gang violence in Coventry. We try to tackle antisocial behaviour and provide opportunities to better young people's future and to keep them on a positive path.
From Warwick Racing, we've chosen to support Fridays by being their technical backers or their technical supervisors. So they'll be building an electric go-kart to compete in the Blair Projects Challenge. And if they have any doubts on how to assemble anything, how to design any components, we'll be there to support. We can also support them with manufacturing, with sourcing of certain maybe hard to get components, and so on.
The main goal for this Friday's Go-Karts project, linked with the universities, is that we are trying to get that team building, that connection, but also get the future and career skills of what you would actually be doing in a business. The branding, the marketing, really working with a team, delegating, talking on the phone, really doing what you'd be doing in the business with the website as well. So it's that team building side, it's the business side, but also if you're actually interested in driving and into engineering, you will be getting opportunities. There's going to be further support that you'll be getting with this opportunity with the go-karts and Fridays, and more interest with racing. If you're interested in racing, F1, there's a chance for you to race in Coventry like they do in Motorfest and against other cities as well.
The site for this project is that it's a film project, and it's going to be one that's going to be engaging all audiences, and one that people that haven't got much experience in go-karting and production will be able to actually develop, because they're going to be training you to actually be able to create these go-karts, create the electrical go-karts that's going to be eco-friendly as well. I'm really excited for that.
I feel like I'll gain electrical skills and get skills with cars and like skills of teamwork and all those sort of skills.
I'll be looking forward to working in a team with creative ideas and sharing ideas and creating a vehicle.
Something that we from Warwick Racing want to make sure is that this competition doesn't just last a couple of months. We want to make sure that the children get a good and long and lasting learning out of this. So the way we're doing this is by, as part of building the car, as part of building the team, we want to teach them about accessing higher education, be it an apprenticeship, be it a university degree. We're going to make sure that we have people from our university and from our team speaking to them about their careers, what challenges they've had, and how they've overcome those challenges. So we want to make sure that the children and the members of Fridays see engineering, see science as something that's cool, something that they want to continue working on, and we want to be able to give them an insight into how you can do that, how you can continue to work, and how you can access F1, or how you can access motorsport, or how you can access the space exploration. They need to be able to see that we've achieved the challenges that they're facing, and we want to help them with that.
Yeah, so all our ideas are from young people. We always ask them on social media, what do young people want? What ideas do you have? What opportunities do you want to bring in? Fridays Coventry, this is your platform. There's endless ideas. We've got the go-karts. We're in the studio right now. This is a Friday's Base Camp Studios where it's going to be for music and business. This is your platform to showcase who you are. Our slogan is unlocking youth potential. Come and show us your talent.
Wow, what a brilliant project. And it's great to see how the university and the students are working with the community in Coventry and with Coventry's rich automotive history, bringing that forward to the young people through this project. Now we'll have the opportunity to hear from Professor Kerry Kirwan about his research. Remember, if you have any questions throughout his presentation, please pop it into the chat. So over to you, Kerry.
Thanks, Evie, and hi everyone, and thanks for being with us. As was mentioned earlier on, one of the reasons for building the racing platforms was to actually show the potential of the materials that have not been widely used, and also spark off some other interesting research questions that might come along as a result of them. So over the next few minutes, I've been asked to take you through what's happened over the last few years. One of the things that we noticed when the F3 car was actually being used in the real world was actually the materials seemed to perform much, much better than what we'd expected. So this sort of led us to wonder whether we could go even further. As we said, we didn't replace any safety critical parts on the world first car because they were there to protect the driver. And if they'd gone wrong, obviously that would be really, really bad. However, we did carry on in the workshop. And as this video shows just how good the recycled carbon fiber systems actually were. On the left is a virgin fiber crash cone, and that material costs and embodied energy is about 90 times that of the recycled equivalent on the right. But the thing to notice is that these are essentially the nose cone of the car, so they need to be pretty good performers, otherwise it would not end well in a head-on crash. So when you see the video, what you'll notice is both components perform virtually the same. Now, the recycled carbon fiber clearly fulfills the requirement of what it needed to do. But remember, the cone on the left cost about £100 a square metre and has a very huge high energy footprint, whilst the one on the right costs about £3 a square metre and was redirected from landfill. So in 2013, we went on to break a land speed record, which is something we didn't quite expect. But what you can see here is the Lola Drayson EV, and you can see two parts on the left. The top one is actually a flax composite, and we use that on some of the wings of the F3 car. And the bottom one is again a recycled carbon fiber composite. Now, the flax part unfortunately didn't make it onto the land speed vehicle itself, not because the materials didn't perform very well, but simply because we couldn't mold them into the shape, the real shape and the smoothness needed for the ultra high aerodynamics that car really had to have in order to break the record. But the recycled carbon fiber part did feature on the vehicle, and this is actually the actual part, and it actually sits right in front of the driver and the front of the windscreen and covers the main console. One of the other materials that we used in motorsport a lot and did feature on the early variants of the world first was glass fiber composites. Now, these are notoriously difficult to do anything with at the end of their life. They don't burn very well in incinerators, and there's no real option for them apart from landfill. So we've been working with European colleagues to try and find ways of not just recycling these materials, but also developing applications for them. And in this instance, you see here, this is an outdoor meeting or coffee space made entirely from recovered glass fiber composites. And they've been ground up and extruded with recycled thermoplastic materials to make construction products. And this actual piece is actually on campus undergoing real world testing with real people using it and in a real environment. And things are looking really promising. And soon we hope to be able to replace minerals that would otherwise have to be mined in some of these plastic products and components that you use outside. Now, we get on to some of the more unusual spin-outs that happen, fatbergs, and there is a link between fatbergs and motorsport. So fatbergs are the horrible big volumes of materials that end up in our sewer systems, and the main cause of them is actually people pouring cooking fats down the sink. Now, we mentioned the biodiesel work earlier on, and what we used there was waste chocolate, but also other fatty materials. So we use things like waste vegetable oil, but also waste fish oil, and although that was a bit smelly for the diesel. But what it did was it allowed us to learn how to separate and clean and then utilize these materials into useful products. So we've undertaken an exercise on campus to collect all the waste oils and fats from our catering outlets And then we've messed around them to see what they can be used for, and see if we could use them as something useful in the future. And if we can, that might stop people throwing it down the drain and causing the fat burn problem in the first place. So after filtering and cleaning, we were able to turn the waste oils into plastics. We actually use these plastics to supplement a standard commercial formula called Degiba, and therefore we reduce the amount of virgin petrochemical material in the composite systems by up to 30%. We also found some property enhancements along the way as well, and we combine this with our recycled carbon fibre understanding to make some really interesting composites. So the bar chart shows 4 different systems: the Degiba systems, they're the commercial ones, and our blended systems. And they were both tried with virgin and recycled carbon fibre. And what we found was actually the blended materials, they became more plastic in nature, which meant they were less brittle and they're better at absorbing impacts. So what we were able to do then is turn them into interesting composite panels for high impact areas, just like the ones on the VLR that James mentioned earlier, and they're good examples of potential applications. One of the other interesting things we got into was wastewater treatment. Again, not one we would have thought of from the outset. So in the UK, we have a huge reliance on our water systems, so that our water is safe and available to drink. But it doesn't require a lot of work to make water clean. One emerging approach is to actually use something called a microbial electrolysis cell as part of that treatment process. They're relatively well known, and what happens is special families of microbes digest the waste in the water, and while they're doing that, they produce both electricity and hydrogen. Now, if we configure their environments correctly, we can essentially turn them into little power generators that actually clean the water for us. And that is what this slide shows. The typical configuration is an anode and a cathode that the microbes live on and do their work as wastewater comes in and flows around them, with clean water coming out the other side. Now, obviously, they don't produce huge amounts of electricity, but pumping water around does consume lots of energy. So any little contribution that we can make can be made to it to offset that energy makes a real difference. And the best analogy is to think of them as little solar panels that help you keep your electricity bill reduced down from the grid. Now, although they're technically possible, one of the biggest issues is their cost. The materials traditionally used are graphite felts, which cost a lot of money. As you can see here, they're over £100 a square metre. So what we were able to do was substitute that with our recycled carbon fibre materials, which came across at just a fraction of the price and also much more readily available to us. And now this is what they look like when they're built. On the left is a single cell, and on the right is a test module that consists of several cells in a tank where the water flows around, being cleaned whilst generating hydrogen and electricity. Now, what we found, and the graph on the left shows the electricity produced. The lines of interest are the blue and the green ones. The blue is the very expensive graphite system, and the green is our recycled system. Now, as you can see, the graphite system produces a high initial output and then slopes off over a period of time. The green one is slower to get going, producing less initial energy, but it is actually gradually increasing over time until they cross and then becomes more productive after about 90 days. Now, the thing to remember is we want these things to last quite a long time. So 90 days on the scale of things isn't actually that much. But most impressively is the hydrogen production from recycled carbon fibre is much more higher than that from the graphite systems. And that's what we're really interested in and working on at the minute, going towards a bigger pilot scale. And this is particularly important as hydrogen becomes part of that renewables future here in the UK. And I should say, we haven't stood still over the last years as well, just doing other things. There was some technology we couldn't deploy earlier in racing, and there's some new ones that have come along that we've been watching and are researching and looking to adapt. So we're working on something quite special that we hope will be ready next year. We've been slowed down a bit from the pandemic, and unfortunately this is as much as I can show you of what it is. But hopefully, given the theme of tonight, given what you've heard from Steve and James and Iqra, you'll get a feeling for what it is we're doing, and you'll get the idea that what's coming next is going to be bigger, better and greener than what we've done before. So thank you very much, and I'll hand you back to Evie.
Wow, I wonder what is under there. That sounds quite exciting, and that is some real cutting edge research you've given us a glimpse into. Thank you, Kerry. So now it's time for your questions. If you haven't already, please put any last questions in the chat. I'd like to welcome back our panel for the questions. Hello again, everybody. Lovely. I'd like to add that we have had a comment from an ex-Warwick alumni talking about the bioresin stuff you were just talking about, Kerry, and saying that that was a very enjoyable experience to work on. Good. So that's brilliant. It's good that we've got some more Warwick people watching. Yeah. So we'll start off with the questions then. Potentially, I'd like to start off with Lucas's question, and he asks, how have any of these technologies been brought forward into Formula One or Formula E or NASCAR from your world first car?
So go on, Steve.
I was going to say I'm not sure any of them have, as far as I'm aware. I think it's one of those difficult things, isn't it? It's for something like Formula One, Formula E, NASCAR, it's all about performance, and unless you can prove that there's a performance gain, you're going to struggle to make these technologies work in that sort of environment, unless of course it's legislated to do that by the race series. That doesn't mean though that the tech, the whole point of the project was to raise awareness and say, actually, there's an alternative here that's worth looking at. Certainly at McLaren, we've done some work looking at recycled fibre and natural fibres in some of our composites. But
I think, Steve, I mean, you're right. Formula One and Formula E, at the very pinnacle, is zero compromise. I think where there's, race series, I think that there are some sort of sports car type series that have started using natural fiber composites for potentially, the bumpers and such, like, because the advantage of using natural fibers, if you have a crash on circuit, you don't leave shards of carbon fiber around the place which puncture tires. So, the natural fibers are actually seeing some quite good use. And I think even McLaren manufactured a seat for an F1 car in natural fiber recently. So there are some advantages. I mean, the natural fibers, sure, you can't get the same strength and stiffness as a carbon fiber, but you do get, improved damping and other factors which can give you advantages. So certainly, a carbon flax composite can give you, good stiffness and strength with the ability to absorb vibration. So maybe in something like a seat or whatever in Formula One, maybe that might see some application. So, but you're right, at the pinnacle, it's a really tough sell for sustainability, unless it's part of the rules.
So I'll just add. I mean, some of the materials are appearing. I mean, James has mentioned the flax recycled carbon fiber sort of composite type things. Those things are starting to appear in certain applications where you're combining the properties of the materials. So the flax, say, acts as a damper, so it absorbs the vibrations. Carbon fiber is really stiff, so things like mountain bikes and things like that, they go in there. But we're starting to see them appear in sort of suspension systems and things like that. The other thing is some of the materials are appearing in some very mainstream automotive cars. They are appearing there. We are seeing some materials appearing in those applications. Not Formula One, but some pretty high spec, high tech mainstream automotive applications. And the other place they're being used is actually in the back of the Formula One, and that in sort of the moulding and things like that. So lots of recycled carbon fiber moulding systems and a bit of the tooling and things like that coming along. So it may not be exactly on the car, but it's opened their eyes where they can perhaps save energy and save carbon somewhere in that process.
So I completely agree. Just quickly, I think some of the things we've talked about making sure there's less embodied carbon in what you're doing, how you're shipping things. Those things are becoming, it's maybe not on the car, but it's things that are becoming massive in motorsport as well as automotive. Making sure that the things that you're purchasing, you're not traveling halfway around the world and back just to just for the sake of it. Trying to make sure that we're reducing our carbon footprint all over is really important, and that's definitely coming through.
Yeah, of course. So we have another question from Will, which I think is for Iqra, and he wants to know what sustainable technologies weren't allowed that you wanted to use on your car, which maybe the rules didn't let you.
I wouldn't say there's something like that. It's a definite no. What you have to look at is the project and your timelines. You've got such a short amount of time to actually design, manufacture, and test this car before it hits the track. And so as a result of that and the amount of testing that needs to take place before you're actually allowed to use, you know, a new material, whether it be a composite chassis structure or something that you actually have to prove its sort of structural safety. So that's something that sort of limited us in the past. And so the approach we take is stick to sort of main components that you know that work. And you can manufacture, and then make slow and small developments. So for us, our main focus has been, you know, the EV powertrain platforms, and that's been working quite well for us. And so over the years, looking more towards the future, we sort of will be looking at, you know, how we can include more sustainable and innovative technologies.
I mean, if we were referring back to the Brands Hatch infamous incident, it was just the fact that, you know, the race class it was entered in had a guest entry into a race class, and they thought it was a really good idea until during the warm-up laps the car was going faster than their pole position car ended up, and then all of a sudden we had a few problems because it sort of did. It was faster, it accelerated, it had a higher top speed, and it did 18 miles to the gallon as opposed to about 8 for the petrol cars.
That was it. It was the fuel economy, actually. I think that was it. We got less fuel.
We got collared on the fuel economy, and then all of a sudden a load of marshals surrounded the car and stopped us going out on track for the actual race because it didn't look so good for the F3 race that was about to happen. So that's our version anyway.
Indeed, but nevertheless, we showed it. It was good fun, wasn't it? I mean, it's where I think there's another question just talking about you know, has there been any interest in everyday sports cars? Now, I think, you know, you can look at websites like B Comp, who are manufacturing, you know, natural fiber composites for sports cars. And you know, it is around and about the place now. It's definitely creeping in, and hopefully, you know, all we can do really is open people's eyes to the fact that these materials are capable. And you know, I think Kerry's right, Steve's right. You know, they have found their way into your everyday automotive. You know, actually Mercedes, BMW, you name it. They, you know, using some quite extensive, you know, sustainable content for their, you know, interior components and such like. So
I guess this is something we're going to have to look out for then in our future cars as we're buying them. Unfortunately, I've had to cut you short there because that is all that we have time for. I would love to thank our panel today. It has been brilliant. So thank you, Kerry, James, Steve, and Iqra. I would also like to thank Emily and Rachel, who are behind the scenes making all the tech work for us, and I think they've done brilliantly. I think everyone today has enjoyed hearing about sustainable motorsports, eco materials, and of course our inspiring work with the community in Coventry, and of course the crazy stuff that the student engineers are also doing. I'd like to thank obviously the Institute of Engagement at Warwick and the innovative materials researchers at Warwick for all this work. If you'd like to join in the conversation on Twitter and social media about what we've done today, don't forget to use #Pint21 at Warwick Engages or at WMG. I'm sure that WMG can get to any other questions that you have on this area which haven't been answered. So what is the takeaway for this evening? I think it's that actually there's a lot more that we can do with our waste than we'd ever expected. And we could be seeing waste products being turned into amazing cars for the future. And I think we need to watch this space from what Kerry has told us tonight, which looks like an exciting project in the midst. So thank you, everybody. Thank you again to our panel, and good night.